Thank you! Thank you!
Hey everyone, I'm Michael Unger, the program coordinator here at the H.R. MacMillan Space Center. If you've ever come into the building before, you may have noticed the shape of the building. Some people think it looks like a UFO. Others, a hide-a-hat. And that's a good reminder, because this building, built in 1968, was built on the unceded territory of the Musqueam, the Squamish, and the Tsleil-Waututh nations. In front of the building, you'll notice that there's a large crab sculpture that was placed here in 1968 by George Norris. And the crab has two meanings. One, the crab is a symbol of the zodiac, Cancer. But also, the First Nations people believed that the crab was a protector of the inlet. Looks pretty cool, doesn't it? Hey everyone, Michael Unger here. Now in my kitchen. It is May the 4th. Happy Star Wars Day, everyone. So glad that you could join us today for the next 45 minutes. We've got another fun little program that we've got for you about the intersection of art and science, all about our favorite space movie, that is Star Wars. We're going to be bringing in some special guests that are going to be delving into this intersection of art and science. Now, for me personally, Star Wars was a pretty big deal in my life. But the funny thing is that it wasn't so much the movies. I had the toys, obviously, as you can see behind me, and I also had these books. And at the front of the book, there was these words that had a big effect on me. It said, "A long time ago, in a galaxy far, far away." Now, this started this path of inquiry when I started to think about what those words meant a long time ago. So this story takes place in the past, in a galaxy, So not the galaxy that we live in, so another galaxy. So there are more than one galaxy out there, far, far away. So the intersection of time and space started to roll around in my brain. And the beautiful thing about Star Wars is that it's such a simple story that you take the universe that we live in, you take the Star Wars universe, and you can compare the two. Now, here's an example. Let me grab some toys here. Here, of course, is the X-Wing fighter. Luke Skywalker's X-Wing that came in to blow up the Death Star. This is a spaceship. But if you look at the rocket behind me, that's the Saturn V rocket that took the astronauts to the moon. Doesn't really look like this, does it? It's long and cylindrical. And as you can see, there's a big explosion happening at the bottom of that rocket. That rocket is using a combustion engine. It's basically a chemical reaction that's causing the force to go down towards the ground, propelling the rocket up into space. But the X-Wing fighter looks more like a plane, doesn't it? And the wings, well, those are to glide over the air. In space, you don't really need that. But as we delve into the Star Wars universe, we see that the X-Wing fighter is one of those spaceships, not unlike the space shuttle that NASA used. It takes off from the planet and then goes into space. So at the back of the spaceship here, we do see those thrusters that maybe they do use similar combustion engines that the Apollo missions use. And then once it gets out in space, boom, now you got some guns to blow up the Death Star there, right? Now, then comes along the TIE Fighter. Now this looks a lot different than the X-Wing, doesn't it? It doesn't have those wings, and it has these vertical wings here. So obviously they're not gliding over air, but it's in space, right? So what could these be? Well, if you look at some of the other spacecraft that NASA has sent up, and you look at the International Space Station, you need power to power a spaceship. So could these be solar panels? Yeah. And the TIE fighter, TIE, stands for twin ion engine, and that's what propels the spacecraft. Not like the combustion engines. The ion engine is a different engine. It's a much more efficient, so you can go longer distances and not use up fuel. And these are the engines that NASA is going to be sending people to Mars. They're using them right now to propel spaceships deep into space. And this is the cool part about Star Wars, is that you ask these questions in this very simple world, the intersection of art and science, and you come to a very deep and much richer understanding of our universe. So for the next 45 minutes, we are going to delve into that. We're going to see how art influences science, and we're going to go the other way around. We have a special guest from Industrial Light and Magic. We're going to see how the science influences the art. So first up, we're going to bring in Rachel Wang, who is our astronomer here at the H.R. MacMillan Space Center. Hey, Rachel, how's it going?
Hi, Michael. Well, so may the 4th be with you.
May the 4th be with you as well, Rachel. So why don't you tell us a little bit about what's your connection to Star Wars?
It started with my dad. My dad and my brother used to watch the movies in the living room, and I would kind of be creeping in the behind and seeing what they were up to. And that really trickled down to me. And I built a lot of Lego Star Wars models with my brother. So it's all really a fond memory for me. Yeah.
Awesome. So a little bit later on, Rachel, you're going to take us into a planetarium presentation, how Star Wars maybe connects to our actual universe that we live in. And then a little bit later on, we're going to be joined by, like I said, a member of Industrial Light and Magic. I'm just asking him to bring in here. There he is. Mihai Cheroba from Industrial Light and Magic. He is the lead effects technical director. Hey, Mihai, how are you?
Hey, Michael. Hey, everyone. May the 4th be with you. Really happy to be here.
Yeah. So, Mihai, why don't you tell us about your origin story? What was your first encounter with this franchise?
The Star Wars universe. Well, you know, the classic starry-eyed child seeing this beautiful sci-fi universe unravel and opening possibilities for imagination and stories and falling in love with science and all that cool stuff.
Yeah, awesome. And so where did you grow up? Where did you first see these films?
I'm from Romania. That's where I grew up, in a small town called Târgoviște. And I saw these films with subtitles. I didn't speak English at the time. And obviously sparked up lots of corners of my imagination.
Awesome. Well, of course, you know, in the universe, there's thousands and thousands of different species. So it just works that Star Wars is a very universal film. So this is an interactive event. If you have questions for Rachel and Mihai during this event, you can put them into the YouTube chat, and we're going to get to those questions. We also sent out some activity instructions for our activity today. And of course, if you completed your activity correctly, you would have some Yoda ears.
Like I'm missing out now.
So hopefully you've got those Yoda ears. You can take a picture. You should tag us on social, Space Center YVR, so that we can see your best Yoda ears a little bit later on. Okay, so before we get to Rachel's presentation, let's, Mihai, who's your favorite Star Wars character?
My favorite Star Wars character is a bit of a controversial one. It's Darth Maul.
Ooh.
He's a bad guy, but the reason I like him is I think he's a really well fleshed out character. He's so consumed by his hatred. It just makes him a really powerful piece of that story. And I know he returns and all that cool stuff.
Have you been watching Clone Wars?
Not Clone Wars, but the main saga.
Nice. Awesome. And Rachel, how about you? Who's your favorite character?
I have to say R2-D2, the pairing of R2-D2 and C-3PO. I love that they're constantly getting into shenanigans and they just have to figure it out. And I feel like I stumble through life in a very similar fashion. And I also have a little R2-D2 programmable robot that I used to play with as a kid as well.
What? You can program it?
Yeah, and it drives around on the floor.
Awesome. Yeah, R2-D2, he's always so helpful. Like he's almost in every film, and I found he's a computer, and he really is the glue to the entire universe. So speaking of R2-D2, we are going to go to a video from one of our partners, NASA, and they have a very special message for us. We're going to take a quick break, and then we're going to come back with Rachel's presentation.
R2-D2, come in. Our Bothan spies have confirmed that the Empire wants to stop NASA from delivering the May the 4th message. You must stop this treachery. Understood?
4, 3, 2, 1, 0. All engines running. Commit. Liftoff.
Hello, Star Wars fans. This is Flight Engineer Rick Mastracchio of NASA on board the International Space Station. Today is a very special day for all of us. Looks like we're having some communication issues. Looks like we're back now. To everyone on Earth from the International Space Station, may the 4th be with you.
All right, let's bring everyone back here, including myself. So Rachel is going to start us off, and we'll bring Mihai in here as well to watch a little bit of Rachel's presentation. And Mihai, feel free to chime in with some questions. But Rachel, why don't you take us out into the universe and see if we can find some of these connections with art in our actual universe?
Absolutely, I'd love to. Just so while I'm waiting for the screen sharing to start, I'll remind everyone that you're looking at a circle or a fisheye view, and that's because I'm using the same software that we use in the planetarium. So this fisheye view, the circle would map to the dome and project the cosmos and planets like this one. And this one happens to be actually the first exoplanet ever discovered. And an exoplanet really is just a planet that exists outside of our solar system. And its name is 51 Pegasi b and was discovered in 1995. Now, this was a groundbreaking find because it meant that Earth-like planets could exist elsewhere in the universe. Now, over half a century later, the 2019 Nobel Prize in Physics was awarded to the 2 scientists credited with the first discovery of an exoplanet orbiting a sun-like star. And their discovery kickstarted an entirely new subfield of astronomy, and scientists began developing new instruments focused on finding and characterizing exoplanets just like this one. Now, of course, in the crazy, fantastical sci-fi universe of Star Wars, not only are exoplanet discoveries a dime a dozen, these worlds are also populated with scavengers and alien creatures. In other words, they're populated with intelligent forms of extraterrestrial life besides humans. Now, so far, there are no indications of life that have been detected on the over 4,000 scientifically confirmed exoplanets that we found so far. And you can see the locations of these exoplanets with these blue markers here. So we don't know if any of these exoplanets are inhabited by Wookiees or Ewoks. But despite this, the science fiction of Star Wars is actually pretty close to science fact. And to show you what I mean, let's visit some real-world examples of Star Wars-like planets. Now, Luke Skywalker's home planet, Tatooine, is plagued by blistering hot deserts and raging sandstorms as it roasts under the sunlight of not one, but 2 suns. Now, officially, its name is Kepler-16b, and it's a Saturn-sized planet located about 200 light years away in the constellation Cygnus the Swan. Now, if you lived on this planet, your shadow would have a twin, and you could watch a double sunset. And each sunset would be unique because the stars are constantly changing positions. And astronomers have found that about half the stars in our own Milky Way galaxy exist in pairs rather than a single standalone star like our sun. Now, our next Star Wars lookalike is not actually an exoplanet, but it's actually an exomoon. It's called the forest moon of Endor, which is the forested realm of the Ewoks, and it's also home to Han Solo's favorite cantina. Now, Endor orbits a gas giant, which is also called Endor because that's not confusing, and like Tatooine, also orbits twin suns. Next up, we have the planet Bespin, the bustling cloud city that floats in the clouds of a cool gas giant like Jupiter or Saturn. Now, mining the atmospheres of gas giants like these ones have always been a staple in science fiction, and NASA has actually looked into this question as well. Now, they found that it was possible to extract gases like helium-3 or helium-4 from the atmospheres of Uranus and planets like Neptune. But many of the gas giants that we found so far are something called hot Jupiters, and they are these massive planets that orbit really close to their host stars. And so close, in fact, that unfortunately they would be way too hot to support floating cities. Now, our next world is a frozen one that lives pretty close to home. Now, we actually do have a planet named Hoth in our galaxy, but its real name is this long thing. So researchers nicknamed it Hoth because no one wants to say that a bunch of times. Now, it's an icy super-Earth that orbits a star halfway from the Milky Way's center, and it was discovered in 2006. But unfortunately, our galaxy's Hoth is too cold to support life as we know it. But life could evolve under the ice of a moon in our very own solar system, and we're flying to it now. It's Saturn's moon Enceladus, which is covered with a very thick ice sheet floating above an underground ocean that could potentially harbor alien life, much like organisms like extremophiles live near the extreme conditions of underwater hydrothermal vents here on Earth. Now, what I can actually do is I can take a cross-section of Enceladus and we can peer inside, and you see this thick ice sheet floating over this underwater ocean. Now, when NASA's Cassini spacecraft flew by in 2015, it passed through a plume of gas and ice spraying out from the south pole of Enceladus. And you can actually see those happening right here, these plumes of icy geysers. Now, one of Cassini's science instruments sniffed the plume and detected hydrogen. Now, the presence of hydrogen is important because it means that this has some source of chemical energy that could be useful to any microbes that live there, if any do. Now, scientists have been searching for exoplanets, these planets outside of our solar system, for quite some time. In the past, we had the Kepler Space Telescope, which found over 2,000 exoplanets during its 4 years of operation. Currently, we have Planet Hunter TESS, looking for exoplanets in this blue area here, which is actually 400 times larger than the area looked at by Kepler. And in the future, we hope to have the James Webb Space Telescope, or JWST, which will help study the atmosphere of known exoplanets, and perhaps even find some larger Jupiter-sized exoplanets. Now, it's designated for launch in March of 2021, so we do still have a few months to go before its launch. Now, both Kepler and TESS use something called the transit method to search for exoplanets. And in fact, TESS actually stands for the Transiting Exoplanet Survey Satellite. Now, when an exoplanet transits or passes in front of its host star, it blocks some of the star's light, just like it did just then. Now, astronomers look for regular or periodic dips in brightness in a star's light curve, and the light curve looks just like this one. And they're looking for at least 3 of these dimming events that may potentially indicate the presence of an exoplanet. Now, when they find such a signal, they log it as an exoplanet candidate to be confirmed later with other scientific tools. And the transit method is one of the most common methods for detecting exoplanets because you can look at or survey a huge portion of the night sky all at once. Now, we found over 4,000 exoplanets so far and counting, but we haven't detected life on any of these planets yet. But I do still have hope for finding droids, humanoids, and other creatures somewhere in the vastness of our universe. In our Milky Way galaxy alone, we have 200 to 400 billion stars, and on average, each of those stars should have at least one planet orbiting it, leaving us with hundreds of billions of more planets and stars to look at. And there are billions of other galaxies out there. So maybe, just maybe, we've yet to look for life in just the right place. And that brings me to the end of my talk. So Michael, I'll throw it back to you.
Awesome. Thanks, Rachel. So yeah, this is full of hope. I love this. They're the 8-year-old Michael and me looking up at the nighttime sky. What I find so fascinating. Are our videos back?
I think so, but you're a little frozen with your hands out right now for me.
Yeah, it looks like my, can you still hear me?
I can.
Okay, well, it's good you can still hear me. It looks like my computer is giving me the spinning wheel of death. So that's not always good. Somebody's. I need R2. R2 needs to come and help me. I'll just let that be, and hopefully the other people behind the scenes can coordinate the chat. But as long as you can still hear me, that's still good. Yeah. So I think what's really cool is back in 1977 when the first movie came out. we didn't have any exoplanets. Alien worlds were completely fiction. And I find this fascinating now that not only is this like commonplace, but almost every single star probably has planets orbiting around it. Is that right, Rachel?
It is, yeah. And I always find that to be a mind-blowing fact, considering exactly how many stars out there and how many galaxies we have as well.
All right. So Mihai, did you have, we'll give you the first shot at a question for Rachel.
I do. I'm a huge space fan, and I was curious, what is your favorite space object, Rachel?
My favorite space object. Ooh. Well, at the forefront of my mind, because we're talking about exoplanets for this week's theme, I do have a favorite exoplanet, and it's actually nicknamed the Planet of Terrors because on this planet, which is called HD 189733b, it's very catchy, it actually rains molten glass because there's a lot of silicate in the atmosphere, and because it's this hot Jupiter, which is a Jupiter-sized planet that orbits really close to its star, so it's very, very hot, it actually turns all of that silicate material in the atmospheres into molten glass. And because the winds on this planet are so fast, they're actually around 7 times the speed of sound, it blows all of this molten glass sideways. And I think that's so crazy that we can have a planet with such bizarre weather like that. Not that I would want to live on it, but it is my favorite exoplanet.
I can already see a concept artist taking exactly what you said and just turning it into this beautiful painting of a new planet.
Yeah, that's my favorite fact to share on Halloween, actually.
Awesome. Thank you.
Yeah.
Awesome, Rachel. Well, we do have some questions coming in. If you have questions, you can put them into the chat in YouTube. And one that I kind of touched on a little bit before, but James Steele wants to know about the technology that we have now at NASA. Would it be possible to have similar aircraft or spacecraft like there is in Star Wars?
Oh, for sure. And actually what's really cool is you mentioned the TIE fighters, Michael, at the beginning, and TIE stands for twin ion engines. And actually we do have a spacecraft that's called the Dawn spacecraft that has not one, not two, but actually has 3 ion engines on board. So we actually are utilizing Star Wars technology now.
Amazing. It looks like I am totally frozen here.
That's okay. You just look really excited about May the 4th.
Maybe you're just on Enceladus.
Yeah.
Yeah, I'm frozen here. I can't share any of the other videos, and I'm gonna have to stop. Okay, well, this is what happens, when you're doing a live event from your kitchen. So maybe why don't we just get right into talking about you, Mihai, and you are the VFX coordinator. The director for Industrial Light and Magic. The lead effects technical director is what your official title is. So maybe why don't you tell us a little bit about what is a lead effects technical director, and how do you contribute to the universe of Star Wars?
Sure, there's a few of us here. The job of technical director is one of my favorites, and because it really ties to that spectrum that we cover so well at Industrial Light and Magic, is that spectrum between pure science and pure art. There's all sorts of artists and engineers and production people that contribute to these beautiful images you see in Star Wars, and a lot of them are on this spectrum. And a technical director is somewhere quite in the middle, where we understand science and mathematics, and we take inspiration from the world, from nature and how it works, and transform it into what we call these algorithms and all sorts of procedural ways of transforming the data, and we output images. Our final output is just the beautiful pixels you see on the screen.
Wow. What inspired you to get into special effects?
I've always been a bit of a tech head, so I have a computer science background, but I've always loved images. So I tried to think, how could I contribute to movies? And there's so many ways to contribute to movies, and one of them is with science. But like I said, at the end of it all, it's images that have to look good.
Oh, I have another question for you. I'm just thinking about how Interstellar is one of my favorite science movies, and that's because they pay such close attention to the science behind it to the point where they could produce papers from it. And they brought in a physicist known for black holes named Kip Thorne. So I'm curious as to how you make the decisions between wanting to keep it as close to science as possible and choosing the artistic license over that.
Right. That's a very good question. Well, first we have a story that comes from talented storytellers and movie directors, and there's a concept we have to bring to life, and a lot of the parts within this concept are can be driven by science and nature. So we start bringing in reference for all the parts that make up the concept, and we take it as far as we can as replicating nature and science, and then the decisions that bring us to the final art direction are coming naturally at a point where we need to depart science because we are storytellers and the images are more important to us.
I see. So you start with the basic science facts, and then near the end, that's where you kind of get that freedom with your artistic license.
Yeah, it's a little bit of that
cool.
circle of science inspires art and art inspires science.
Yes, and that's my favorite circle of them all.
Awesome. So can you guys see me now?
Yes.
Yes.
And you can hear me okay?
Yes,
Awesome.
welcome back.
Yes. So thanks, Rachel, for taking over there. Mihai, we're going to get into some of the images that you worked on because you worked on all of the new trilogy. I see you've got a Rise of Skywalker t-shirt on. You worked on Force Awakens, Last Jedi. We're going to look at some of those images, but I did an interview with your teammate Mike Jutan, who's in R&D, research and development. So a little bit of a different angle at Industrial Light and Magic. It was a really fascinating conversation. We put it on up our YouTube, and right now we're just going to watch a little bit of the work that he did on the Mandalorian. So we're just going to take a quick little break here, watch this clip, and then we're going to come back and we're going to delve into some of your images, Mihai.
Part of what's been fun about collaborating on The Mandalorian with Lucasfilm and Disney is that we have been able to see through a few technical innovations and a few firsts that I think are going to have a lot of impact on the way television and movies are made moving forward. In partnership with ILM and Epic, we have put together a system whereby which we can have game engine, real-time render, and video wall technology coming together to create a backdrop for the big, beautiful world of Star Wars.
The volume is 21 feet tall, it's 75 feet in diameter.
Yeah, so that was really cool. So my conversation with Mike Jutan was really fascinating because what's really was going on is that he kind of comes from the math world, and I was really fascinated to hear that someone like him would work with someone like you, Mihai, and you, because you have a little bit more of an artistic angle, you're able to kind of like solve some of those problems when you're trying to create these worlds, and the intersection of art and science really comes together in your teamwork. Could you maybe talk a little bit about sort of like how you work with the rest of the team at Industrial Light and Magic?
Yeah, absolutely. Yeah, Mike is a fantastic R&D engineer, and we put great value in our research and development at ILM. They make some of the tools that we use, and we can't do without. It's just like painters need specific brushes to create specific paintings, you know. So Mike is exactly at that end of the spectrum where he's using heavy research and development and mathematics and all sorts of physics to create tools for that move into the artistic spectrum. And we cover all that zone there. There's all sorts of talented artists that fit everywhere here. There's painters on the other side of the spectrum, and there's R&D engineers here. Us technical directors fit somewhere in the middle, where we are able to use slightly more complicated tool sets and science and mathematics, but also turn them into images. Yeah, there's a few disciplines that are there. I'm part of a discipline called effects. I participate in all the stuff that can't be animated by hand. Let's say if it's not a character, it's some sort of natural phenomena like fire, smoke, water, even magic, lightning, clouds, all sorts of strange things like that.
Well, speaking of strange things, let's look at some images here. And what I'd love to do, Mihai, is I want to show you some images from the Star Wars universe. And I'd like you to sort of talk us through, kind of like tell us sort of like what's going on. And maybe from your standpoint, some of the scientific questions that you would ask to create some of these worlds. And then Rachel, maybe you can help us out here and kind of give us some context, some real world context to how these worlds really work. So we'll start with, let's see, let's start with this one here. This one's, well, we'll start with the very latest one from Rise of the Skywalker, since you've got that shirt on. And this scene is really cool. Of course, Kylo Ren and Daisy Ridley are fighting, and there's a lot going on here. So Mihai, take us through what's going on here.
Yeah, so this action here happens on Kef Bir. It's one of the uninhabited moons of the gas giant Endor, I believe, and it's a water world, a little planetoid, and these are the remains of a destroyed Death Star, and that's where they're fighting. So what I think is really, really cool here is, and this beautiful sequence was executed so stunningly by our Singapore team. And what I find really cool here in our space talk is how these worlds can actually exist. And this is a full water world where the strong gravitational fields of the gas giant can create such huge waves and oceans.
Yeah, so Rachel, maybe take us through a little bit about there. So we're talking about a water world that is not like a calm lake here. This is a very chaotic water world. So how does a strong gravitational pull create a world like this?
Right, so it works similar to the way that our moon affects the tides here on Earth. So you can imagine, let's, for example, take a cracked egg. So the egg yolk being the Earth and the egg white being the water. And we have tides twice a day. And the reason for this is because the moon exerts a gravitational influence on Earth, just as Earth does on the moon. And what it does is you can imagine that, well, the moon exerts a force on the water, so it makes the tides bulge a little bit. And we also have the moon exerting a gravitational force on the Earth, so it pulls the Earth a little bit. And if you sum these two pictures, then you end up getting these two bulges on either side of the planet. And that's only with the moon. The moon is a lot smaller than Earth is, so it doesn't have a lot of gravitational influence, that force pairing that you have between the Earth on the moon on the Earth. So if you had a planet with a lot of water on it that was near something like a black hole, much like Miller's planet in Interstellar is near Gargantua, the black hole, just like that, then you would have these massive tides. So that bulging that you see here on Earth is way, way, way bigger than we would ever get here. So yeah, so definitely, I don't know if I would want to visit a planet or a moon like that, but it would be a cool thing to see from afar.
Awesome. Let's go to another one here. Another one that's a movie that had come out. Let's go to this one here. So we learned about the Kessel Run in the very first Star Wars film, and then we actually got to visualize it in Solo. So Mihai, maybe take us through here, sort of like some of the questions that you might have asked in visually creating the Kessel Run here from Solo.
Yeah, so this is one of my favorite things, and I actually worked on this sequence with our team here at ILM Vancouver. This is the famous run that Han Solo did in 12 parsecs. And in slightly over 12 parsecs, it made him really famous. And what I think is really cool here is it's a depiction of interplanetary space. So what could be out there in between all these space objects that are planets and stars. And what the Kessel Run is this huge storm, a space storm, and we took inspiration from all sorts of space images that are out there, and we invented this storm full of debris, like we call them carbonoids. It's asteroid made of carbon, and they crash into each other and it create all sorts of debris. It's a dynamic place. There's clouds of hydrogen and helium, and most importantly, there's these. It's very charged, so we are using lightning bolts to create dramatic events and shape the chase. There's a chase here. It's the Millennium Falcon chased by some TIE fighters, and we use the lightning bolts to shape the ships and create this dramatic feeling of chase.
Awesome. Now, before we go any further, Rachel, I think you do need to define and maybe correct George Lucas's original mistake about the word parsec, because that is actually an astronomical term, right?
It is. A parsec is 3.26 light years. And it really comes from parallax, which is this way of looking at distances in our nighttime sky. And you actually have parallax when you hold out your finger and you close one eye and then close the other. You see your finger kind of shift in positions, and that is actually parallax happening. And so it's just this weird definition that happens to be 3.26 light years.
Great. And then very quickly, so the Kessel, for that, what Mihai is sort of like describing is sort of like a bridge between these two worlds. Is this something that we might find in the universe?
So I love scenes like this, these chase scenes when you're dodging through things like asteroid fields. But unfortunately, I actually do mention this when we're in the planetarium as well, when we're flying through an asteroid belt, that they're actually a lot less dense than you would see in films like Star Wars. Actually, if you were flying through, like Han Solo on the Millennium Falcon, through an asteroid field, the chance of you hitting an asteroid is actually less than 1 in 1 billion. So it's not as dramatic as I would like in real life, but I love scenes like this.
Awesome. Let's go to another one here, and this one is really, really interesting. This one is from Rogue One, and this is a planet that we have seen before. Obviously, Rogue One is set right before A New Hope, and it's on Yavin. So Yavin is a moon of a gas giant. Mihai, maybe walk us through. This is a really beautiful image. Maybe tell us a little bit about it.
Yeah, I chose. It's as simple as that. I chose this image from our library just for the beauty of it, and I personally am really fascinated by gas giants. Jupiter is my favorite planet in our solar system. And I always thought it would be so amazing to inhabit one of those planets and just have a huge gas giant rising and setting, you know. And this is part of the Star Wars universe.
Rachel, so you did talk about Enceladus in your planetarium talk. So that is obviously not a very forested moon like Yavin here. But what would be the chances that we might be able to find a world like this that people could actually live on this close to a gas giant?
Oh, you know, Mihai, when you were saying that, like, just imagining yourself living on a planet like this, I am right there with you. I would love to see something like this. In terms of whether or not we'd be able to find something like this, I never rule anything out because our universe is massive. It's 93 billion light years across. That's many, many, many parsecs. But in terms of being able to see something like this, a planet or gas giant like Jupiter in the heavens being that close, I would love to see something like that and see all the dynamics of Jupiter's crazy intense atmosphere.
Awesome. Let's go to one final image here, and then we're going to take some questions from the audience. And let's end it off here with another just stunning image that your team created, Mihai, and that's the Death Star here that is just coming up over the horizon. And this is a small moon as it's first described, but is an actual place, you know, that people worked on here. What were some of the questions that you might have asked in creating the visual aspect of the Death Star?
Well, just like you said, Michael, it's like another celestial body here. It's like a rising moon, and the reason I chose this image for the presentation is because it's an artificial object, and I think there are plans out there for the far future for humanity to create planetary-sized objects, and maybe even star-sized. I heard of something called the Dyson sphere, which is maybe I'll let Rachel talk more about it. I think this is again about that circle about how art influences science and vice versa. And I thought it was beautiful.
What do you think, Rachel? Tell us a little bit about the Dyson sphere.
Right, so I'm right there with you. I really do think that all the crazy ideas that we have now in STEM really are born from sci-fi, and the Dyson sphere is one of them. The Dyson sphere is this hypothetical massive structure that aliens or us could build around a star, and it's supposed to harness a star's energy. And the cool thing about that is that when a civilization does build a Dyson sphere, it would be exponentially fast to do so, because when you're trying to harness a star's energy, as you're building these solar light panel things that are surrounding the star, you can harness that energy to build faster the other panels that you're going to build around it in this Dyson sphere. So my big hope for the next planetary scale thing that we'll do is actually the Dyson sphere, because I feel like that would be a very cool idea to harness energy.
Awesome. So for the last little bit of the program here, we're going to open it up to all the viewers out there. If you have any questions, put them into the chat. I think I might have missed a couple here, but we'll go through some of them. So first off, for you, Mihai, do they use any physical models when doing the special effects for the modern Star Wars film, or is it 100% computer generated?
Mm-hmm. Tricky question. Yes, we do, but we hide them really well, and we marry them really well with computer graphics imagery, and also sort of very close to the idea of models and reality-based visual effects is the latest of ILM, which is Stagecraft, which is something that was used in Mandalorian, and I just love how it's such a beautiful storytelling tool.
And if we go back, a question for you, Rachel, we're talking about the Goldilocks zone. Can gas giants not exist close enough to a star to have a moon or another planet in a warm enough area?
So the Goldilocks zone, or the habitable zone, is this region where it's not too hot, not too cold, and it's just right for liquid water to exist, just like the fairy tale. And so what's interesting about hot Jupiters is that they actually orbit within things like the habitable zone, because it's just so hot where they're orbiting. They're orbiting very, very close to their host stars. So they have very, very high surface temperatures and atmospheric temperatures. So
Yeah. So, and when you describe that, like the hot Jupiter, so Jupiter and Saturn and these worlds that when we're talking about gas giant, these are not worlds that we will be able to find life on, right? Like maybe it explains sort of like basically what a gas giant is, as opposed to like the terrestrial worlds that we were just looking at.
Exactly. So we live in our solar system's habitable zone, and Jupiter and Saturn and those planets are outside the habitable zone, meaning that they're icy and they're really, really cold. But you could have liquid water existing even outside or exterior to this habitable zone through things like tidal friction. So like the idea of rubbing your hands together and it gets really, really warm. The same kind of thing happens with planets like Enceladus, or moons like Enceladus, that have these liquid water oceans, and that's because of the gravitational forces of Saturn on Enceladus and Saturn that has this tidal heating that allows liquid water to exist, even though we expect that liquid water shouldn't exist there.
Awesome.
Is that why Enceladus is cracked? Because of those gravitational pulls?
Exactly, and that's why it has an underwater ocean, because of that tidal heating or gravitational heating.
Did we just give you an idea for maybe some visuals on the next Star Wars film, Mihai?
The little wheels are spinning now.
Awesome. Question also from the audience from Emma. She's asked Mihai, are there any tips you would give for world building? I would love to know the process of how you come up with such amazing concepts. So maybe walk us through that a bit, Mihai. So somebody obviously has given you a task, you and your team, to kind of like problem solve and maybe build a world. But how much of a blank slate do you have to work with? Like, how many details do you have, or are you just having to come up with it on your own?
I wish I could take some of that credit for building worlds like that. Unfortunately, I don't build worlds, but there's really talented artists in Industrial Light and Magic that do. They are called concept artists, and they are painters by trade, and they take inspiration from our world, from images from everywhere, and they put them together in various ways and create variations of these worlds, and then these variations are cycled through with the art director and the directors themselves, and slowly they hone in more and more to the final concept. But it takes a lot of work and a lot of paintings to get there. The main idea here is to just keep inventing. Creativity is never linear. There's always change. Things always move around, and sometimes even after a certain concept is approved, it may take a few steps forward, but because of the way it fits in the story, or better yet said, the way it would fit better if it would be changed a little bit, then we go back to it, we revisit, right. And so it's a very organic process.
Cool.
So creating these worlds is something that I wish I could do, but the fingers really put us to shame when it comes to images.
Another question from Marguerite. Could you tell us a bit more about how the lightsaber is animated to look so believable? And is the lightsaber possible in scientific theory? So that's probably maybe Mihai, take that first half, and then we'll throw to Rachel for the second half.
Yeah. So the lightsabers started as an optical effect on the original films, and it was so cool, and it became such an iconic image that preserving the look of those lightsabers was of utmost importance. Nowadays we do them digitally. On set, the actors are yielding light emissive objects. But in the end, we create them with computers, and there's all sorts of optical effects added on top of that. They start in animation, and they end up with us in effects, and then they go to compositing, which is the department that puts all the layers together of the shot, including the plate photography and all the elements that we generate, and they make one final believable shot.
Has the look of the lightsaber, has it evolved over the course of like the last 40 years or so?
The original ones we try to keep as close as possible, like Luke's lightsabers, all of those classic ones, right? However, Kylo Ren, for example, is a new character in this new trilogy, so his lightsaber is quite different. Is very frenetic. It's made out of these flames almost that are just constantly vibrating. There's quite a few elements in the lightsaber, and then the compositing department puts everything together, gives them all that beautiful glow.
Cool. And then of course, Rachel, maybe let us know about the realistic possibility of these lightsabers.
Right. So a lightsaber is really closer to a light bulb than it is to a laser. And you can see this in day-to-day when you have a laser pointer and you point it somewhere. You don't see the beam until it hits a wall or hits your hand or something. And with a light bulb, you're really emitting light in all sorts of directions. And that's what a lightsaber is doing. And there's a fun fact, actually, that I went to go see Donna Strickland, who was a recent Nobel laureate, and she is a world-leading expert in lasers, and someone had asked her a question about lightsabers specifically, and she said that she absolutely hated them because they weren't possible in real life, unfortunately.
Oh, too bad. This comes pretty much at the end of our program here. I'll throw one last question out to you, Mihai. In all of the films that you've worked on, within the Star Wars universe, and maybe others that have involved space, has your perspective of space changed at all now that you actually get to work in these worlds and create these worlds?
It hasn't. Again, I go back to that circle of art influences science and science influences art, and I love how in Star Wars they're able to travel so fast. So my hope is that one day humanity will be able to travel as fast as they do, and we can explore different worlds, and why not make contact with all those civilizations that talk funny like the Ewoks.
Rachel, can you? How close are we to light speed travel?
Faster than light? Well, we do have a few ideas that in theory should work, and in practice we haven't quite tested it yet. I haven't quite fleshed out all the details, but things like Alcubierre's warp drive, which is deforming space-time faster than the speed of light and kind of like riding a space-time wave. That's one idea for faster than light travel. We also have wormholes, but all of these still exist in the realm of theoretical physicists' heads, so not quite there yet.
Awesome. Well, thank you so much, Rachel and Mihai, for joining us, and everyone out there for watching. May the 4th be with you, our Star Wars Day. Hopefully this has inspired you. We are going to be launching a contest today for the next couple weeks for any of you out there that may be inspired to make your own films. And it's really easy now. You know, if you grab your own phone, you can make these little short little films and send them into us. You can use your Legos. You can use basically any objects that you have, maybe your toys, maybe some utensils, and make a story. And it doesn't have to be very long. Yeah, exactly. Rachel's got her little robot there. And send them into us. We're going to be reviewing these little films, and the most creative one, of course, you may not have Mihai to help you with some of the special effects, but what we're really looking forward to here is sort of like the intersection of art and science. Whoever can come up with some really good ideas. We've got some gift cards to kids' books that we're going to give away to some of the winners. So the deadline is going to be Monday, May the 18th. And we actually got one submission in already of a little film made from Legos. And I won't play the whole thing. I'll just play the beginning of it here. Came to us from Moses. And let's just have a little look here. This is really cool. Thank you so much to Moses, who's 11, I think. He sent that in. So if anyone out there, if you were inspired, send it in. You could win. Of course, everyone out there watching, thank you so much. If you'd like to donate, so we can continue doing these online programs for you, please go to our website, to the Donate Now button. We're going to be sending out surveys that we can hear back from you about the types of programming that you'd like to see on these channels. Rachel is going to be doing live Q&As every Thursday, and because we got into Star Wars here this Thursday, our theme is going to be, what is it going to be, Rachel?
Exoplanets. And I'll talk a little bit more about my favorite exoplanet if you want to learn more about the planet with molten glass on it.
Awesome. So join us at 2 o'clock on Thursday to ask Rachel some more questions about exoplanets. And then even a little bit later on, Rachel, you were talking about the tides. We're going to have a whole week talking about tides as well, because they are a bit complicated. I can't wait for that one. That's it for me, folks. Thank you so much for joining us. Another May the 4th. Mihai, thank you. Rachel?
It's a pleasure.
See you next time.
Bye, everyone.